Hello guys, this is Bisa again. Today our topic about redox reactions. The reactions in which both oxidation and reductions are involved, which are called redox reactions. The reaction in which both oxidation and reduction are involved is called redox reaction. So the best example for this redox reaction are zinc plus copper sulfate uses to zinc sulfate plus copper. Correct? In this, zinc is a neutral atom. So the oxidation state of zinc is zero oxidation state, and here Cu plus 2 SO4 minus 2, and here copper carries plus 2, and zinc here plus 2, here copper again 0. During oxidation, loss of electrons conditions. During oxidation, the first condition, loss of electrons, addition of oxygen, third one, removal of hydrogen, and the fourth one, addition of more electronegative atom. During oxidation, the first condition, loss of electrons, addition of oxygen, removal of hydrogen, addition of more electronegative atom. So based on these conditions, here from zinc to zinc plus 2, here 0 to plus 2 means loss of electrons. So loss of electrons also considered under oxidation reaction. So this condition carries oxidation. Correct? Next step, during reduction, here loss of electrons means oxidation, gain of electrons. The second condition, addition of hydrogen, removal of oxygen, addition of hydrogen, removal of oxygen. Next, removal of more electronegative atom. Removal of more electronegative atom. So during oxidation, these conditions; during reduction, these conditions. Correct? Based on this, zinc loses 2 electrons. 0 to plus 2, that is oxidation, losses electrons. And here plus 2 to 0 means gain of electrons. Gain of electrons means reduction. So here reduction. Correct? So these type of reactions are best example for redox reactions. The reaction in which both oxidation and reaction are involved is called redox reaction. Oxidizing agent means the reagent which oxidizes to other substance and it itself reduces takes place, which is called as oxidizing agent. Correct? In case of reducing agent, the reagent which reduces other species and which itself oxidizes takes place, that is reducing agent. A best example for this both oxidizing and reducing agent is here x plus a uses to x power n plus a power n minus. Correct? Here 0, here 0. From 0 to plus means loss of electrons. So here oxidation. Here oxidation. Here 0 to minus means addition of electron, that is reduction. Reduction takes place here. Correct? In this A to AN minus means reduction. For this reduction, this is a reducing agent. So in this chemical reaction, X is called a reducing agent. Reducing agent. And here, which it itself oxidizes takes place. So this is a reducing agent. And for this oxidation, this A acts as oxidizing agent. Why? Because the reagent which oxidizes other species and which itself reduces takes place. So this reduces takes place. So in this chemical reaction, X is reducing agent, A is oxidizing agent. Clear? Yes. Now, balancing of redox reactions. A redox reaction can be balanced by two methods. What are those? The first one is ion electron method, which is half reaction method, and the second one is oxidation number method. Now we are going to discuss about ion electron method. A redox reaction can be balanced by two methods. What are those? Ion electron method, that is half reaction method. And the second one is oxidation number method. Oxidation number method. Now we are going to discuss about the rules of ion electron method. This method only applicable for ionic form. Only applicable for ionic form. Now, rules for ion electron method. How we can balance this reaction based on these rules. Correct? Now, first one, rules. First one, ion electron method. Only applicable for ionic form. And rules. The first rule is write the skeletal form of reaction. Write the skeletal form of reaction. The second rule is write the oxidation number on each atom and identify oxidation half reaction and reduction half reaction respectively. Means we have to separate out this oxidation half reaction and reduction half reaction. Next, the third one is balance the atoms other than oxygen and hydrogen. Means except oxygen and hydrogen, if there is any atoms is present, then we have to balance for that atom. Correct? Now, the fourth one is balance the oxygen atoms by adding required number of water molecules to the deficient side. Correct? Next, the fifth one is balance the hydrogen atoms. So, for balancing hydrogen atoms, there are two conditions are there. The reaction in acidic medium, the reaction in basic medium. In acidic medium, what is the condition for balancing hydrogen atoms? Here, already I gave in acidic medium, the hydrogen atoms are balanced by adding required number of H plus ions to the deficient side. To the deficient side in acidic medium. In basic medium, what is this? The hydrogen atoms are balanced by adding required number of water molecules in deficient side. And the same number of OH minus ions opposite side, on the opposite side, correct? So these are 5 points. The next sixth point, the sixth rule for balancing redox reaction is, now balance of charge can take place by adding of electrons on the right side of oxidation of reaction and the left side of the reduction of a reaction, correct? Now the seventh one, correct? Now cross multiplying the oxidation of reaction and the reduction of reaction by the respective number of electrons and then add both the oxidation of reaction and the reduction of reaction to get complete balanced chemical equation, correct? Now we are going to discuss about balancing redox reactions. Now the question is, balance the following equation in acidic medium by using ion electron method. We have to balance this chemical equation, correct? Now before going to balance the chemical equation, first we have to find out the oxidation numbers of each atom in the following chemical equation. Now for MnO4 minus, here MnO4 means here X plus 4 into minus 2 is equals to minus 1, x minus 8 is equals to minus 1, x is equals to minus 1 plus 8, that is plus 7. So here manganese plus 7 oxidation state, here sulfur plus 4 oxidation state, here already plus 2, here sulfur HSO4 minus means plus 1 plus x minus 8 is equals to minus 1, x minus 7 is equals to minus 1, x is equals to minus 1 plus 7 is equals to plus 6, correct? So here sulfur carries plus 6 oxidation state, correct? Now I am mentioning that MnO4 minus plus SO2 gives us to Mn2 plus HSO4 minus. Here manganese plus 7 oxidation state, here sulfur plus 4 oxidation state, manganese plus 2, again sulfur plus 6 oxidation state. Already we discussed before about during oxidation means loss of electrons. So from plus 7 to plus 2 means gain of electrons. So here reduction takes place. Here reduction takes place. Why? Because gain of electrons. And here plus 4 to plus 6 means oxidation number increased. Oxidation number increased means loss of electrons. So this is oxidation. This is oxidation. Now both oxidation and reduction takes place simultaneously in a single chemical equation. So this type of chemical equation is also called a redox reaction. Now we have to separate oxidation of reaction, reduction of reaction. Correct? SO2 gives to HSO4 minus MnO4 minus gives to Mn plus 2. This is reduction of reaction. Another side is oxidation of reaction is SO2 gives to HSO4 minus. So this is reduction of reaction, oxidation of reaction, correct? So what is the first condition? Balancing the atoms other than oxygen and hydrogen, correct? Balance the atoms other than oxygen and hydrogen atoms, correct? So here other than oxygen and hydrogen means only manganese is there, correct? So how many manganese atoms here? 1. Here also 1. So no need to balance the other than oxygen and hydrogen. As usual I am taking MnO4 minus J raised to Mn plus 2. Correct? Here other than oxygen atoms means oxygen and hydrogen atoms means sulfur, sulfur. Here also one sulfur and one sulfur. So no need to represent here SO2 J raised to H SO4 minus. Correct? Now the second condition for balancing oxidation, balancing oxygen atoms. Balancing oxygen atoms. So for this balancing oxygen atoms means the required amount of water molecule should be added at the deficient site. Correct? Now here MnO4 minus J raised to Mn plus 2 plus 4 water molecules. 4 water molecules. Why? Because here 4 oxygens, here there is no oxygen. So 4 water molecules should be added at a required site. Now here 2 oxygens, here 4 oxygens. So here 2 oxygens. So how many water molecules should be added here? 2 moles. So SO2 plus 2 water molecules used to HSO4 minus. This is what? Balancing oxygen atoms. Now in acidic medium, balance hydrogen atoms. Balance hydrogen atoms. Balance hydrogen atoms. In acidic medium, the required amount of H plus ion should be added at a deficient site. Correct? Now here only oxygens. Here how many hydrogen atoms are there? 4 into 2. Totally 8 hydrogens are present at the right side. Now we have to add 8 H plus ion at a deficient site. Means this side. So MnO4 minus plus 8 H plus used to Mn plus 2 plus 4 H2O. 4H2O. And here 2 into 2. 4 hydrogens. Here only 1 hydrogen means the required amount of H plus ions 3. Why? Because already 1 hydrogen is there. So SO2 plus 2H2O used to HSO4 minus plus 3 H plus ions. Correct? Next. Charge. Balance charge. Charge means we have to add number of electrons. Means we have to add electrons. Here -1 plus 8 plus 8. Choose. Why? Because how many pluses? 8 pluses, so plus 8. And here plus 2. And this is the neutral molecule, so 0. Correct? Here plus 7 uses to plus 2. How this will be neutralizes? How many electrons should be added at the left side? Means for plus 2. Here we have to add 5 electrons. If we add 5 electrons, plus 2 will be equal. So MnO4 minus plus 8H plus 5H2 Mn plus 2 plus 4H2O. For here 0 plus 0 uses to -1 plus 3. Correct? This is the neutral molecule 0. This is the neutral molecule 0. For this HSO4 minus means 1 minus 1. Here how many pluses? 3 pluses. So 0 uses to plus 2. Plus 2 means here if you add plus 2 electrons in this side, then it will be neutral. Correct? So plus 2 electrons should be added here. Now SO2 plus 2H2O uses to HSO4 minus plus 3H plus 2 electrons. Correct? Now finally we have to cross multiply. Means how many electrons we added here. That number should be multiplied with this complete reaction. And here how many electrons? 2 electrons. These 2 will be multiplied with this complete reaction. So just I am taking this is equation 1 and this is equation 2. Correct? Now we have to calculate equation 1 into 2, equation 2 into 5. So 2MnO4 minus plus 16H plus 10 electrons uses to 2 Mn plus 2 plus 8 H2O. Correct? And for this one, 5 SO2 plus 10 water molecules uses to 5 HSO4 minus plus 15 H plus 10 electrons. Correct? Correct? For this balancing cross multiplying, these 10 electrons will be cancelled. Then after, here how many H plus ions? 16 H plus ions. Here 15 ions. So these 15 H plus, remaining 1 H plus is there. Correct? Now how many water molecules? 10 water molecules, here 8. 8 water molecules cancelled and remaining 2 water molecules are there. Correct? Now the complete balanced equation is 2 MnO4 minus plus 5 SO2 plus H plus 2 water molecules uses to 2 Mn plus 2 plus 5 HSO4 minus. So this is the complete balanced equation of above chemical equation in acidic medium.